Picture the darkest place you've ever stood. No streetlights. No moon. Only the breath of cold air and the hush of distance. Now imagine looking up and seeing Jupiter, a banded giant filling half the sky, its rings razor thin, storms boiling in slow motion. Beneath that alien glow orbits a world that may hold more water than Earth and oceans sealed under ice, rumbling with tides and humming with energy. That world is Europa. And as you watch this, NASA's Europa Clipper is already on its multi-year journey to meet it. With one audacious question at the heart of everything: could there be life in that hidden sea? Europa Clipper isn't a lander, and it isn't a Europa orbiter. It's a heavyweight investigator that will orbit Jupiter and repeatedly swoop past Europa nearly 50 times, scanning, sampling, and listening. Why the flyby strategy? Because Jupiter's radiation belts are brutal. Lingering near Europa would fry a spacecraft in short order. So Clipper plays a cosmic game of tag. Dive in close, grab as much data as possible, then retreat into safer space to downlink and reset for the next pass. This clever choreography both reduces radiation exposure and maximizes data return, and it's exactly how we LL map an entire moon, slice by slice, pass by pass. Closest flybys will skim to just approximately 25 kilometers, 16 miles above the surface. So close you could resolve ridges, pits, and shattered plates of ice in stunning detail. Let's ground this in the roadmap. Launch. October 14th, 2024, atop SpaceX's Falcon Heavy from Kennedy Space Center. Why Europa, and why now? Ever since the Galileo spacecraft flew past in the late 1990s, Europa has been a nagging whisper in planetary science, a global saltwater ocean beneath an ice crust. Tugged by Jupiter's gravity, potentially venting plumes into space, where seawater meets energy like at hydrothermal vents, life blooms in darkness. If Europa combines liquid water plus chemistry plus energy, it checks the 3 boxes for habitability. Europa Clipper exists to test those boxes systematically. It will probe the thickness of the ice. It will search for organics and salts at the surface. It will listen for the ocean by reading how Europa disturbs Jupiter's magnetic field. If the answers line up, we won't just have a target wheel, have a blueprint for where to land next. To pull this off, Clipper carries one of the most focused scientific payloads ever fielded for an Ocean World 9 instruments, plus a gravity science experiment, each chosen to attack a piece of the habitability puzzle. Few stars of the show. Reason: a dual-frequency, ice-penetrating radar, sound through the crust to reveal internal layering, brine pockets, and possibly the interface where ice meets the ocean. This is our X-ray vision for a world of ice. EIS Europa Imaging System will shoot ultra-sharp images to map fractures, chaos terrains, and fresh deposits that could point to recent activity. MES, a near-infrared spectrometer, will fingerprint surface chemistry, water-ice phases, salts, and organics. ETHEMIS will scan for thermal anomalies, subtle hotspots that might betray recent eruptions or warm-up wellings beneath the crust. ECM Europa, Clipper magnetometer, and PIMS, plasma instrument for magnetic sounding, work as a team to read the induced magnetic field proxy for ocean depth and salinity, while disentangling the noise from Jupiter's charged particle environment. Together, they form a cross-checking network. Images point to targets. Spectra decode their chemistry. Radar profiles their depth. Thermal maps flag hotspots. And magnetic plasma readings reveal the ocean's character. But before the good science can happen, the spacecraft has to survive where very few machines can. As one JPL engineer put it, Jupiter has the most intense radiation environment other than the Sun in the solar system. To cope, Clipper carries its avionics inside a radiation vault, a thick-walled sanctuary of metal that acts like a bunker. Dramatically reducing the total ionizing dose the electronics will accumulate during years of flybys. The flight plan also limits time spent skimming Europa's deadliest zones. It's the difference between taking a quick lap through a thunderstorm and camping under a lightning rod. Logistics matter too. Clipper is solar-powered, with vast wings to sip sunlight 5 times farther from the sun than Earth. Every flyby will be an Olin sprint. All instruments run together, hoarding data during minutes of closest approach. Then, safely back in wider orbit around Jupiter. The spacecraft turns homeward, dumping its memory through NASA's deep space network over days to weeks. Only then will the team finish poring over one pass and begin planning the next, using which fractures to cross, which chaos terrains to profile, and which potential plume crossings to chase. This rinse and repeat rhythm approach, observe, retreat, downlink, plan is how we'll transform a cryptic ice ball into a detailed atlas. And there's a reason for the urgency. If plumes really vent water vapor from Europa's ocean through fissures in the ice, then a well-timed flyby could directly sample ocean materials sputtered into space. No drill required. Past Hubble observations hinted at such plumes, though they're elusive and intermittent. Clipper's strategy, dozens of passes at varying longitudes, latitudes, and times, maximizes the odds of catching Europa in the act. Even without a plume, surface chemistry can still betray the ocean's secrets as salts and organics well upward and freeze on the skin of the moon, ready for spectrometers to taste. There's also a practical human story here. Europa Clipper is a generational effort. With costs on the order of $5 billion through its prime mission, supported across administrations, and propelled by a growing ocean world's vision at NASA, it stands shoulder to shoulder with ESA, Astute mission already en route to the Jovian system, setting up a powerful 1-2 punch of exploration in the early 2030s. Clipper arrives first. JUICE follows about a year later with a deep focus on Ganymede. Together, they'll remake our view of the outer solar system, not as a frozen backwater, but as an archipelago of oceans. Timeline check. After launch in October 2024, Clipper stretched its solar wings and began commissioning instruments. It took a Mars gravity assist, then an Earth flyby to bend its path outward. Each maneuver carefully trades momentum to shape the final 2030 Jupiter arrival. This isn't a straight shot. It's a chess game played in celestial mechanics, where every move is measured in months and millions of miles. When Clipper finally slides into Jupiter's grasp, the team will execute a series of burns and moon flybys to set up the cadence of Europa passes. Nearly 50 flybys over several years, some low enough to skim a mountain's height over the ice. So what does success look like? Not a headline that screams life found, but a body of evidence that says, with confidence, Europa isn't habitable. Maybe radar lines up a thin, nice corridor over a warm upwelling. Maybe spectrometers flag salts consistent with an ocean in contact with rock, hinting at hydrothermal chemistry. Maybe the magnetometer reads an induction signal that demands a deep, salty sea beneath the crust. And maybe, just maybe, a fortuitous pass sniffs a plume rich in organics, pointing the way to a future lander's touchdown zone. That's the prize. Clarity. The kind that lets the next mission carry a drill, a melt probe, or a tiny submersible design, not just to ask about habitability, but to search for life itself. In the end, Europa Clipper is a bet that some of the most Earth-like places in the cosmos are not on planets at all, but under ice, far from the sun, warmed by tides and time. If that bet pays off, it will change the map of where we look for life. From Enceladus and Titan in Saturn's realm to Pluto and beyond. The ocean worlds are calling. Europa, with its cracked white face and restless sea, is first in line. When you strip away the poetry and the promise, exploration comes down to one question. Why risk billions of dollars and decades of work on a frozen moon 500 million miles away? The answer lies in what Europa represents: a cosmic mirror of Earth, a test case for life beyond our atmosphere, and perhaps the clearest shot we've ever had at finding it. Let's start with the basics. Europa's ocean may hold twice as much water as all of Earth's seas combined. That's not speculation. It's grounded in hard geophysics. When NASA's Galileo spacecraft orbited Jupiter in the 1990s, it discovered that Europa induces a secondary magnetic field, a telltale sign of a conductive liquid under its ice. Salt water fits the bill perfectly. Later Hubble observations revealed faint plumes erupting from Europa's limb geysers, possibly connected to that vast subsurface ocean. Though controversial, these hints fueled the momentum that birthed Europa Clipper. The logic is simple. If water is the cradle of life here, why not there? On Earth, life thrives in the strangest corners: boiling vents on the seafloor, acidic pools, Antarctic subglacial lakes, locked under miles of ice. In 2013, scientists drilled into Lake Vostok in Antarctica, sealed off from sunlight for millions of years, and found microbial signatures. In Yellowstone's hot springs, extremophiles dine on sulfur. In the deep oceans, tube worms flourish in pitch black, nourished not by sunlight but by chemosynthesis. These analogs are more than curiosities, they are previews of what Europa could harbor. A world sealed from the sun but fed by tidal flexing, volcanic vents, and chemistry beneath its frozen armor. Europa's surface itself is a map of violence and renewal. Unlike our moon, scarred by craters billions of years old, Europa's crust is young, geologically speaking, maybe 40 to 90 million years. That freshness means resurfacing, a churn of ice plates, and possibly material rising from below. The infamous chaos terrains, regions of jumbled blocks, tilted slabs, and frozen slush, look eerily like pack ice on Earth's polar seas. If water or slush wells upward, freezes, and resolidifies, it might carry traces of the deep ocean with it. That SY Europa's skin is as important as its sea. It might be the page on which the ocean has scribbled its secrets. Europa Clipper is designed to read that page with forensic detail. The Europa Imaging System eyes will zoom in with resolutions down to 0.5 meter per pixel and some flybys sharp enough to spot boulders and ridges. Compare that to Galileo's best images, which often blurred features several kilometers wide, and you realize how blind we've been. With EIS, we'll see Europa in a clarity that no human has ever seen before. But clarity is not just about beauty, it's about targeting. If future missions are to land on Europa, they'll need safe, scientifically rich spots. Imagine choosing a landing site on Earth by looking at satellite photos taken from Mars that ask the challenge we've faced until now. Europa Clipper will rewrite the atlas, flagging promising areas where ice may be thin, plumes may erupt, or fresh deposits may betray chemistry from the depths. Then there's reason, the radar. Dual frequencies can probe from the surface down tens of kilometers, depending on ice purity. For the first time, we may detect the ocean boundary, or at least subsurface lake stepping stones between ice and sea. It's as if we're about to get CT scans of an alien world. Reason finds thin spots or water pockets. Those become bullseyes for the next wave of missions. But Europa Clipper's genius is not just its instrument sit, it's how they talk to each other. Let's play out a scenario. Imagine the spectrometer MES flags a region rich in salts and organics. Radar reason shows a subsurface lens of liquid just beneath. The thermal imager Athamas spots a faint warmth at the same site. And the magnetometer records a local anomaly consistent with salty brines. Each clue alone is intriguing. Together, they paint a coherent story. Here lies an active conduit between surface and ocean, a window into the abyss. That synergy is what makes Clipper more than the sum of its parts. To put this in perspective, think about the Cassini mission at Saturn. In 2005, Cassini flew through plumes at Enceladus, another icy moon, and tasted salty water laced with organic molecules. That single daring pass reshaped our understanding of habitability. Cassini wasn't even designed for that job, yet it delivered gold. Now imagine a spacecraft built entirely to chase that kind of discovery. Not once, but 50 times. That's Europa Clipper, and Clipper isn't alone in this dance. Across the Atlantic, the European Space Agency's JUICE mission is on its way. Launched in 2023, targeting Ganymede, but scheduled for multiple Europa flybys too. By the early 2030s, 2 spacecraft, 1 American, 1 European, will be orbiting Jupiter, cross-checking data, and building the most complete profile of the Jovian system in history. It's international science at its finest, echoing the cooperative spirit of the International Space Station, but stretched across 500 million miles of vacuum. All of this, of course, comes at a cost. The Europa Clipper project has ballooned to over $5 billion. It's making it one of NASA's most expensive planetary missions ever. Critics ask, why not spend that money on Earth, on climate, healthcare, poverty? Proponents counter. Exploration is not a zero-sum game. Technologies born here, radiation shielding, deep space navigation, advanced solar arrays filter back into industry and defense. The inspiration fuels STEM careers. And perhaps most importantly, the search for life addresses humanity's oldest question. Are we alone? If even microbial life exists elsewhere, it rewrites biology, philosophy, and perhaps even religion. For many, that answer is worth the investment. there's another layer too. By pushing spacecraft to endure Jupiter's wrath, we test the engineering that may one day protect human missions to Mars or beyond. Every challenge Clipper overcomes radiation, power scarcity, long-duration autonomy becomes a lesson for future explorers. It's no accident that Spacex, with its Falcon Heavy, is part of the story. Commercial launchers now underpin our most ambitious science, reducing costs and expanding possibilities. The public-private partnership is no longer theoretical, it's the backbone of 21st century exploration. Still, nothing about this mission is guaranteed. Jupiter is unforgiving. Radiation can degrade electronics faster than models predict. Instruments may underperform. A single misfire in trajectory correction could doom a flyby. The spacecraft must operate largely on its own, with commands uploaded hours or days in advance, because light takes nearly an hour to make the round trip from Earth. This is a ballet where every pirouette is scripted in advance, and mistakes are punished ruthlessly. Yet that's also the beauty. When Clipper returns its first close images, every pixel will be a triumph of planning, persistence, and patience. And then there is the tantalizing possibility that Europa won't just whisper, but shout. Imagine this. During one of its earliest flybys, instruments detect a plume, unmistakable. Spewing water vapor into space, Clipper dives through, its mass spectrometer pseudo-catching grains of ice, analyzing them on the fly. The data shows salts, organic molecules, perhaps even amino acids. Instantly, headlines erupt. Signs of life's building blocks discovered on Europa. It won't mean life confirmed, but it would electrify the scientific world, push governments to fund a lander, and maybe even set the stage for humanity's first mission designed explicitly to hunt for alien organisms. That's the cliffhanger hanging over this entire mission. Not just will we find life, but what will we dare to do if the signs point to yes? Will Congress fund the billions more for a lander? Will international coalitions form? Will the public's imagination ignite the way it did with Apollo? These questions remind us that space exploration is not just about rockets and sensors. It's about willpower. It's about whether we, as a species, are prepared to follow the evidence wherever it leads, if that evidence points to biology on another world. As the countdown to 2030 ticks away, one truth is unavoidable. The next decade will either confirm Europa as a sterile ice ball, or elevate it as the prime candidate for life beyond Earth. And Europa Clipper, quietly coasting between the planets, is carrying that verdict in its memory banks. By the time Europa Clipper arrives at Jupiter in 2030, an entire generation of scientists will have waited decades for this moment. For some, it's the culmination of careers. For others, it's the launchpad of a new era. But Clipper isn't just a science mission. It's a story of ambition, resilience, and humanity's insatiable need to know. Let's rewind for context. The idea of exploring Europa didn't begin in the 2010s, or even with Galileo. As far back as 1979, when Voyager 1 and 2 flew past Jupiter, Europa stunned scientists with its smooth, bright surface, streaked by mysterious dark lines. Unlike crater-saturated Callisto or volcanic Io, Europa looked different, almost alive. Those linear fractures looked like cracks in ice, like something had stretched and broken the crust from within. Planetary geologists knew instantly. This was not a dead world. Something was happening beneath. And if there was activity, there could be water. If there was water, the questions of biology weren't far behind. From then on, Europa became an obsession. Galileo confirmed the ocean in the 1990s. Hubble teased the possibility of plumes in the 2010s. Papers piled up, conferences buzzed, and follow the water became NASA's mantra. Yet funding never came easy. Missions were proposed, shelved, resurrected. In the 2000s, Europa was nearly explored as part of a joint NASA project, but costs spiraled and politics interfered. The dream seemed always within reach, but always slipping away. Finally, in the mid-2010s, Congress mandated Europa Clipper. It was too compelling to ignore, too tempting to let fade into PowerPoint slides. That persistence tells us something important. Europa is not just a moon. It is an icon. It's the embodiment of one of science's boldest promises, that alien oceans might hide alien life. and it represents a frontier humanity cannot resist. But while the mission excites dreamers, engineers know the dangers. Picture a spacecraft hurtling past Europa at 4 miles per second, about 6 kilometers per second. Instruments must switch on, stabilize, and gather data in a window of mere minutes. Imagine trying to photograph a speeding bullet as it passes by your window, while also sniffing its chemical makeup and listening to its vibrations. That's the scale of challenge Clipper faces during every flyby. The timing is ruthless. It's a command sequence, and the once-in-a-lifetime data could vanish into the void. Radiation is the constant villain of this story. Jupiter's magnetosphere is so fierce, it can strip electrons from atoms, bathe surfaces in charged particles, and fry unprotected electronics within hours. Europa itself sits inside this radiation bath, meaning every pass is like flying through a storm of invisible bullets. Clipper's radiation vault is ingenious, but it doesn't make the spacecraft invincible. Each flyby is a calculated risk, every circuit a soldier in a war against entropy. By the mission's end, Clipper will be scarred, weakened, but hopefully victorious, its databank bursting with revelations. For the scientists, though, every scar is worth it.
Consider what's at stake.
If Clipper proves Europa's ocean is salty, deep, and in contact with rock, that points to hydrothermal activity, the same process that fuels life at Earth's vents. If organics are detected, it suggests prebiotic chemistry. If plumes are real and analyzed, we may taste the ocean without digging. Even if Clipper finds no organics, that result is just as important. It defines where habitability ends, setting boundaries for life in the cosmos. The drama of discovery is not limited to science. Europa Clipper also symbolizes the marriage of exploration and culture. Think about it. Every great age of discovery has its icons. The 15th century had caravels and compasses. The 20th century had Apollo and the Saturn V. The 21st century will have probes like Clipper daring to reach alien oceans. These missions are the myths of our time stories our grandchildren will learn in school. Tales that show how far curiosity can push us. And don't underestimate the psychological impact of even the hint of life elsewhere. When Viking landers touched Mars in the 1970s, ambiguous results about soil chemistry ignited decades of debate. Imagine the shockwave if Europa Clipper reports amino acids or other complex organics in a plume. It won't be proof of life, but it will shatter our complacency. Suddenly, the idea of life beyond Earth won't be abstract. It will be data, a graph, a spectrum, a measurable fact. At that moment, Europa becomes not just a moon, but the first true alien ocean within our reach. Calls will grow louder for a lander, perhaps even a cryobot that can melt through the ice. Already, NASA has conceptual studies. Europa Lander, Enceladus Orbalander, Titan submarine. They exist on whiteboards and in proposal drafts, waiting for the spark that Clipper may ignite. The truth is, Europa Clipper is the reconnaissance scout, the mapmaker. The next mission will be the diver. And eventually, if humanity dares, the colonist. We should pause, though, and recognize the fragility of this pursuit. Missions fail, rockets explode, budgets collapse, public attention drifts. To keep this dream alive requires not just engineers and scientists, but storytellers, educators, and citizens who care enough to demand answers. That's why videos like this, channels like yours, and conversations across the world matter. They keep Europa in the spotlight, so that when discoveries arrive, the world is ready to listen. Let's also consider the ethical side. Suppose one day a probe dives into Europa's ocean and finds microbes, strange and alien, but alive. What then? Do we celebrate, or do we hesitate? If we send future landers, how do we ensure we don't contaminate a pristine biosphere with Earth's bacteria? Planetary protection isn't just bureaucracy. It's a moral question. If Europa harbors life, it belongs not to us, but to the universe. Our responsibility will be to study without destroying, to touch without corrupting. In this sense, Europa Clipper is not just about exploration, but about learning how to be better stewards of discovery. Its careful flybys, its reliance on remote sensing rather than drilling reflect a philosophy. First, look, later, touch. Eventually, maybe, embrace. But only with wisdom. Meanwhile, public anticipation builds. NASA has teased the sleek spacecraft in assembly, its solar arrays stretching wider than a basketball court, its instruments glinting under cleanroom lights. Update sparks headlines. Europa Clipper wings attached, final testing underway. The countdown to launch in October 2024 has already begun. And every milestone adds tension to the story. Will Falcon Heavy roar flawlessly? Will the gravity assist line up? Will the instruments all awaken on cue? Every step forward is another turn in the drama. Another reminder that space exploration is equal parts science and suspense. And when Clipper finally departs Earth, trailing the hopes of billions, it won't just be another spacecraft in the sky. It'll be a symbol that humanity still chooses wonder, even in an age of cynicism. It will be proof that we are willing to invest not only in what we need, but in what we dream. Because at the heart of this mission lies a question that transcends science. Are we alone? It's a question that unites tribes, nations, and generations. Farmer in Kenya, a student in Tokyo, grandmother in Argentina, wonder about life beyond Earth. Europa Clipper is humanity's collective attempt to answer. To pierce the silence of the cosmos with instruments and antennas and human imagination. So as 2030 approaches, we wait not idly, but with anticipation sharpened by history. From Voyager to Galileo, from Hubble to Cassini, each step has led here. Now it's Clipper's turn. Soon Europa's secrets will no longer be the property of speculation. They'll be data, images, spectra, truths we can hold in our hands. And when those truths arrive, they will challenge us, not just as scientists, but as a species. The clock is ticking toward the 2030s, and with each day Europa Clipper drifts farther from Earth and closer to destiny. By then, we may be living in a different world politically, technologically, and culturally. Yet one truth will remain constant. When Clipper makes its first daring pass over Europa, the eyes of humanity will turn to a frozen moon orbiting Jupiter. But why does this mission matter beyond the laboratories and observatories? Why should ordinary people, far removed from the details of magnetometers or spectrometers, care about Europa? The answer is woven into our history. Humans have always chased horizons, crossed oceans not because we needed to, but because we wondered what lay beyond. We climbed mountains not because it was safe, but because they were there. The voyage to Europa is the next expression of that impulse, the drive to explore not just for survival, but for meaning. Europa Clipper represents the fusion of curiosity and capability. We finally have the technology to ask questions Galileo hinted at decades ago, and these questions are not trivial. They strike at the roots of philosophy. Is life an Earth-only accident or a cosmic inevitability? If Europa's ocean harbors microbes or even the precursors of life, then biology is not a fluke. It is a pattern, a law, as natural to the universe as gravity or starlight. That discovery would not just reshape science, would reshape our sense of place. Think about the ripple effects. If life is confirmed at Europa, how would religions respond? Some might see it as proof of creation's vastness, others as a challenge to dogma. How would politics shift? Nations may unite behind space exploration, seeing it not as competition, but as shared destiny. How would culture evolve? Children might grow up knowing they share the cosmos with unseen neighbors, however small. The idea of us would expand from a single planet to an interplanetary community of life. But even if Clipper finds no organics, no promising chemistry, the mission will not be failure. It will be clarity. Negative results are still results. They will tell us that habitability requires conditions beyond water, that oceans alone are not enough. That too is profound, because it sharpens our search. Instead of scattering our attention across every icy body, we will focus on those with the right combination of water, chemistry, and energy. Europa Clipper is the filter through which our search strategy for alien life becomes smarter, sharper, more focused. Now let's look forward. Picture this. The year is 2032. Data from dozens of Europa flybys floods NASA servers. High-resolution images reveal ridges only meters high, blocks of ice sliding like tectonic plates, and chaos regions where the crust is collapsed into frozen slurry. Radar profiles show pockets of brine close to the surface. Spectra confirm salts consistent with seafloor hydrothermal interaction. Thermal maps detect faint warmth hotspots possibly linked to subsurface upwellings. And then comes the moment the mass spectrometer detects complex organic molecules in a suspected plume. The press conference is electric. Scientists speak cautiously, but the headlines scream. Europa's ocean may be habitable. What happens next? Funding bills are introduced in Congress for a Europa lander. The European Space Agency accelerates plans for a joint mission. Private companies pitch concepts for cryobots, submersibles, even sample return technologies. Universities launch new programs in astrobiology. And suddenly, the conversation about life beyond Earth is no longer confined to science fiction, it is a practical agenda. At the same time, humanity will wrestle with new ethical frontiers. Suppose microbes are discovered. Do we leave them alone, guardians of their own ecosystem, or do we study them directly, risking contamination? Planetary protection guidelines will need to be enforced with unprecedented rigor. Every screw, every circuit of future landers will need sterilization beyond what we've attempted. And we'll face questions that blur science with philosophy. Do alien microbes have intrinsic value? Do they have rights? Or is their destiny to become specimens for human microscopes? Europa Clipper won't answer those questions, but it will force us to ask them. That's the power of exploration. It expands not just our knowledge, but our responsibilities. There's also the human dimension of hope. Missions like this are reminders that amid our crisis wars, pandemics, climate change, humanity can still aim upward. We can still build something beautiful, something audacious, something that reminds us of what we are capable of when we work together. The sight of Europa Clipper unfurling its vast solar arrays in deep space is a kind of poetry in itself, a fragile machine carrying our collective curiosity into the unknown. And don't underestimate the inspiration factor. Just as Apollo inspired engineers, scientists, and dreamers in the 1960s, Europa Clipper could ignite the imaginations of millions in the 2030s. The first color mosaics of Europa's fractured plains will hang in classrooms. Documentaries will dramatize the flybys. Children will write essays about becoming astrobiologists. The seeds planted by Clipper may blossom into the workforce that eventually takes humanity beyond Earth entirely. Let's return to the image we began with. Standing on Europa's surface, looking up at Jupiter's massive disk dominating the sky. It's a sight no human has seen, but one Clipper will help us imagine in detail. When we see those close-up images, icy ridges sharp as blades, planes glowing faintly under Jupiter's light, we LLB, glimpsing the stage for one of the greatest dramas in science. Whether or not life is there, Europa will become more than a dot of light through a telescope. It will become a world with character, mystery, and maybe, just maybe, companionship. Because here's the truth. Europa Clipper is not just about Europa. It's about us. It's about our need to reach beyond the boundaries of our small world, to find kinship in the cosmos, to prove that our questions are not in vain. It's about turning the cold silence of space into a dialogue, one data stream at a time. So when the first flyby images arrive, when the first spectra are analyzed, when the first hints of habitability emerge, remember this. You are living in the age when humanity first reached for an alien ocean. Long after we are gone, those discoveries will remain. Long after our headlines fade, the data will still sing. And maybe somewhere in the dark sea beneath Europa's ice, something will be singing back. The journey has just begun. And with Europa Clipper, humanity's next great story is already on its way.